Hello all, and thank you so much for being here. My name is Audrey Euler,
My name is Simran Kulkarni.
And I'm Patrick Sicarelli.
and today we will be talking about harnessing energy through your very own movements.
To begin, in 2023, approximately 750 million people lacked access to electricity due to a multitude of reasons, including supply chain disruptions, as well as a lack of affordability. As our world continues to evolve, our need for electricity across all areas is increasing rapidly. So, in order to create a more equitable society, it's imperative that we create more sustainable and efficient methods to create energy for all.
Triboelectric nanogenerators, or TENs, are a viable solution to this energy crisis. The triboelectric nanogenerators use the triboelectric effect to convert mechanical energy into electrical energy and the triboelectric effect is the phenomenon that when two dissimilar materials come into contact with one another, they transfer electric charges between each other, and then when they're separated, a difference in charge is resulted between them, which results in a voltage between them. There are 4 different components to triboelectric nanogenerators, which include the charge generating layer, the charge trapping layer, charge collecting layer, and the charge storage layer. And the charge generating layer also has 4 different working modes, which you can see in the picture. And that includes the vertical contact separation mode, which we will be focusing on, the lateral sliding mode, single electrode mode, and freestanding triboelectric layer. The vertical contact separation mode works by having 2 dielectric materials, which are also called insulators. Those 2 materials are attached to current collectors, and then when they meet, their charges transfer because of their different electronegativities. And then when they're separated again, a charge difference is seen between them, and then the current collector can collect that voltage. And then the charge trapping layer traps the charges generated so that they can be used at a later time. And then the charge collecting layer collects the charges generated to transfer them to a different external circuit or electronic device so that they can be used to power them. And that charge storage layer is an optional addition to the triboelectric nanogenerators that can temporarily store the charges so that they can be used for a later time and then transfer to an external electrical circuit at a different time.
All these aspects make TEN easily applicable to a multitude of things. Some other things that allow triboelectric nanogenerators to be easily applicable to a variety of sources include its traits such as its biocompatibility, its small size, and its high power output in relative to its size. These TEN technologies are able to be applicable to something specifically as in textiles, which is the thing that our group decided to focus on. In textiles, electronic components such as power storage systems and transducers can be embedded into fibers. There are 2 main methods in which triboelectric nanogenerators are embedded into these textiles. Method 1 is through integrating triboelectric materials onto conductive fibers by electrospinning. Electrospinning is the process in which conductive fibers are created through malleable polymers being welded into extremely thin fibers, which are then made into the textiles. The other more common method is to incorporate TEN technology straight into the fabrics, and then using these fabrics to create wearable textiles, which is the process that we decided to focus on for our example. Our group decided to focus on the example of TEN textiles in shoe insoles. As stated before, TEN textiles work through contact separation. So, when these TEN textiles are inside the shoes, as seen in the image below, they can work as energy cells. So as our bodies go through mechanical movements, either through walking, running, or any everyday movements, the mechanical energy becomes converted into usable energy, which is then stored in the energy cells. In addition to acting as energy cells, These nanogenerators are able to act as sensors, which are able to record acceleration and the frequency of people's motion. Because of this, they're able to track and more efficiently and effectively record energy and convert it to be used in the future.
Now that we know the technology behind Tang and how it is used in everyday movements, what are the actual pros and cons of this technology? The benefits of Tang include its small size, allowing for it to be lightweight and flexible across a whole bunch of applications, and also have the ability, as we know, to harvest energy from even the slightest of movements. Tang can be seen beyond just wearable electronics. It can also be seen in wind and water power generators. As Tang is a small-scale device, it can be used in large-scale applications, such as in wind and water, as I mentioned before. Wind and water power is a reliable source of sustainable energy. However, there are places on the Earth that lack the availability of having constant moving water or constant moving winds. So when using Tang devices into these generators, you can increase the reliability because Tang in small-scale applications is able to harness even the slightest of movement. However, the drawbacks of the Tang technology include its inability to handle supplying energy for large-scale applications. This would include powering your house or powering a factory, where electromagnetic generators would be a better use for this. However, Tang is best seen in small scale than being implemented into large. Now, on the aspect of sustainability, Tang in of itself is sustainable. It is able to harvest energy from your very own movement, meaning that an external force is not necessarily needed, besides your own body force. But the material for this technology can either be made from renewable or non-renewable resources. Research has been shown that the materials made for Tang can be made from environmentally friendly materials, such as from animal fur, plant leaves, cotton fabric, and microorganisms. As seen in the image, fish scales can be used in the friction layer, as Patrick was mentioning before. And in here you can see that the fish scales can equate to an equal power output voltage as using non-renewable resources. However, in large-scale applications, like in the wind and water power generators I was mentioning before, these are more reliable because biodegradable materials eventually will biodegrade. So when using these non-renewable resources, such as precious metals like aluminum and copper, it is extremely energy intensive to mine these, causing great health and environment effects.
In conclusion, Tang technologies create an innovative and sustainable solution to our energy crisis. With Tang technologies, we'll be able to create more energy for people across the globe, no matter where you're from. So, your step can power the future of the energy system.
Thank you.
Thank you.
So I'm not sure if I understand. So you have this in your shoe, and you're storing this power. Could you then use it maybe to like charge your cell phone?
Yeah, there's research been shown that the walking of your own movements can actually light a light bulb.
Some of the applications that we were able to see, although we did focus on just the power storage, the power that has been stored has been seen to charge your phone, light up to 80 volts of electricity, and even power a GPS system.
I could see it heating your shoes, so you're
You guys talked about like specifically application shoes, and are there any other small applications that would be like wearable and seen in the future?
Yeah, so although we focus specifically on shoes, Tang technologies are being implemented into a variety of things, including pacemakers and electricity creating shirts so that people can use it while they're running in order to light up. Although we didn't focus specifically on those, the technology itself is just aimed to use your own mechanical energy to create a power system. So, yeah.
So how exactly is the energy transferred? Like, is it possible that the sole in the shoe can like break and like electrocute you or something, or is the transfer process so safe?
So in the things that we did see, because it is still in the innovative process, it is a very like thick sole in order to keep the energy storage safe, but it hasn't been used in human trials yet because the technology itself is still in its innovative phase.
And adding on to that, the device itself is like a few millimeters or even centimeters, so it's not big enough to really like affect you in any way if something would happen.
I just had a question regarding affordability. Did you look into like, is it in fact more affordable than like electricity, general electricity would be?
Yeah, so the technology itself, while being created, because it does take off of other nanogenerators such as Triboelectric nanogenerators, the creation of the device is expensive at first, but over long term, since it's only taking mechanical energy, which is free, we're all creating it right now, in the long term, the energy creation would be less than the energy cost of lighting up